Or they're not given anything yet?
Nothing said.
No, sir.
Okay. I think you all told me, your Bandra kids told me, like maybe first 6 chapters tentatively. Okay, guys, see. So this part is got a lot of application. Just 1 or 2 definitions to mug up. Otherwise, there is just application only, and there are some numericals. But then there are also simple numericals in this one. So, guys, what is law of gravitation states now? So it says that between any 2 objects, any 2 bodies. For example, let's say here we have a object A, and there is other objects here B. So between any 2 objects, like for example A and B, there will be a force of attraction. So whatever objects are there around you, for example, there may be a glass of water, whatever objects are there, chair, table, they all have a force of attraction between them. Now, this force of attraction, guys, it is directly proportional to the product of their masses. So M1, M2. What are M1, M2? Masses of A and B. And this force is also inversely proportional to the square of distance of separation. Now, what do you mean by distance of separation? So the distance which is between the center of A to the center of B, that is called as what? Distance of separation. Okay, I don't know if you remember, this same factor now we had done it in the A part of the chapter, non-contact forces. Clear, everybody? So force is directly proportional to the product of masses, inversely proportional to the square of the distance. Now, if you want to combine these 2 equations, okay, if you want to combine them, then what will it become? F proportional to M1, M2 upon R squared. Just 1 second, guys. Okay, guys, so if you combine these 2 equations, what will we get? F is proportional to M1, M2 upon R squared. Okay, sorry, this is raised to 2. I wrote it very close. So it is R raised to 2. Now, if you want to remove this proportional sign, do you remember what you have to put if you want to remove a proportional sign? You have to insert a constant. Okay, that constant out here now, guys, is what, G, capital G. So F is equal to G, M1, M2 upon R squared. Okay, now, guys, if you cross multiply, what will you get? G equal to FR squared upon M1 into M2. Clear, everyone? So this is the formula for G. G is what, guys, out here? I'll repeat once again. Gravitational constant. Okay, now what is the value of the gravitational constant? So the value of gravitational constant is 6.67 into 10 to minus 11. So we don't have to learn how the value is derived or something. You have to just know the value by heart. Okay, now what is the units? So what will be the unit of force, guys? Tell me. Ashi, unit of force?
Newton.
Newton. Unit of distance?
Meter.
Meter. So meter squared. This is what? Kg. This is what? Kg. Got it? So this will be Newton meter squared per kg squared. Clear, everyone? These are the units. So you have to by heart these units, guys. They can ask you what are the units also out here. or they can, and they can ask you the value also. So both the things you'll have to by heart over here. Okay, anybody having doubt, guys, still here, out here? So between any two objects, there is a force of attraction like A and B, and A is of mass, say m1, B is of mass m2, and then you can see F proportional to m1, m2, F proportional, inversely proportional to r squared. Okay, I have one question. Navya, if the mass increases, let's say this mass increases of A, so what happened to the force? Increase or
So
decrease?
force will increase. So
Correct,
the
it will
force will
increase. Correct, because they're directly proportional. Angel, if this distance is increasing, then
Then mass will also increase.
A. If the distance will increase, what will happen to the force, Angel?
force will decrease.
Force will decrease.
Force will decrease, yeah, because more the distance, lesser the force. Okay, guys, now let's take one example. So, say out here we have got two objects of masses, say, one second. Two objects, one is of mass 1 kg, and other object is also of mass 1 kg. Distance between them is 1 meter. What is the force of attraction between these two objects? Hey, you're understanding what I'm saying? Let's say on your table right now, there are two objects, two books are there. Approximately 1 kg. And they both will have a force of attraction between them. Like they both will move towards each other, supposed to move each other like a magnet. Okay. What is the force between them now? That force is equal to G m1 m2 upon r squared. What's the value of G? So 6.67 into 10 raised to minus 11 into mass 1 kg, 1 kg. What is the distance between them? 1 meter. So 1 squared. You solve all these equations, what do you get? 6.67 into 10 raised to minus 11 Newton. Clear, everyone, guys? So this is the force of attraction between these two objects. Just notice how small the force is. Look at the value, 10 raised to minus 11 Newton. Very, very, very small. Okay. But see, now what? Now this, tell me what would have happened if this mass, instead of 1 kg, was 10 raised to 7 kg. You know what happened? The force will get converted into 10 raised to 7. Got it now? Because n1 is 10 raised to 7. So we'll multiply here 10 raised to 7. And then the value of this will change drastically. So what is the moral of the story? As this mass keeps on increasing, the force also will keep on increasing between them. Now tell me, do you see those objects which are there on your table? Are they moving towards each other right now? You can check around. They must not be moving. Okay. And so, guys, now next thing. Now I'll tell you why these objects are not moving, even when the law of gravitation says there is a force of attraction between them. So now look at this very, very important example, guys. Let's say here, this is the surface of the Earth. Okay, this is the Earth surface. And out here we have an object A. There is another object here, B. So between A and B, guys, what have we learned? There is a force of attraction. Correct? So there is a force of attraction exerted by A on B and force of attraction exerted by B on A. You know which force will be greater, A on B or B on A?
They will be
Guys, which
equal
will be a
now.
greater force? Sure. Correct. They will be equal forces. Both the forces will be what? Equal. Why are the forces equal now? Okay, because that's the law says, like the force of attraction between them is equal, directly proportional to masses and inversely proportional to square of distance. Guys, now, next thing, Naisha and Vidhi, why your camera off? Aditya, Geet, Riyajan. Maisha, are you aware of what's happening here in the class or no? Why do you have to put your camera off? Geet, Aditya. Okay. Guys, next thing. Now, so guys, just like A and B are attracting each other, na, same way, there is also a force of attraction between A and the Earth also. So between them also, there is a force of attraction. So there is a force of attraction exerted by A on Earth and force exerted by Earth on A. Both of them are happening, guys. But what again these forces are what? These forces are equal. I'll repeat once again, guys. A is attracting Earth. Earth is also attracting A. And both of them are what? Equal forces. So most common mistake is what people feel that no, Earth will attract A with a greater force. Remember, it does not attract with a greater force. They both attract each other with the equal forces. Okay, now my question, next question, Gia, which force is greater? Force exerted by Earth on A or force exerted by B on A? Which will be a greater force?
Earth, right?
Correct. Force exerted by Earth on A will be greater. Why is that force greater? Because why is that force greater, Gia?
Mass, because Earth has more mass, right?
Very good. Yes, because Earth has a greater mass, it will also have what greater force of attraction. One more thing, Angel, I said A attracts Earth and Earth also attracts A, right? Both are attracting each other with equal force. Then why does A go towards the Earth? Why not Earth going towards the A?
Because Earth attracts more.
No, they attract each other with equal forces. Then why do A go to Earth and not Earth to A? Anybody?
Because the mass
Aditya?
of Earth is more, na?
Very good, Nisha. Guys, Earth has a very large mass, great or greater mass. Hence, it will also have what greater inertia. And because it is a greater inertia, it will not move easily. Instead, it will pull the A towards the Earth. Okay, now let's say that A is some object. This is hypothetical. Huh? Let's say A is some object whose mass is greater than the mass of Earth also. Okay, I'll repeat. Mass of A is much more than the mass of Earth also. Then what will happen? How will the objects move? Earth will go to where? A. B will also go to what? A. Everything will go around or go to A. And so this law is also used to explain the motion of the Earth around the Sun, Moon around the Earth. So see, who's attracting Earth? Sun is also attracting Earth same way. Got it now? Who's attracting Moon? Earth is also attracting Moon in the same way. So because there is a force of attraction between them, that's the reason those planets are also moving around in the same way. Okay, clear everyone, guys, this application? They can ask you some questions based on this. Clear? Okay, now next thing, guys, now we have learned two formulas for finding the force on a body. So see, this derivation which I'm doing now, this derivation had come in your school paper. It has come twice, I remember, in last few years. So very common question to be asked in your school paper. So see, what is this derivation about now? So this object A, okay, for this object A, as I said, this body is experiencing what force, right? Who's pulling it? Earth is pulling it. That is according to law of gravitation. There is one more formula force we've learned. What is the other formula we've learned, guys, for force? Force is equal to
M into A.
M into A. But if a body is falling freely, then what is the acceleration it will have? Acceleration due to gravity. So we've got this formula, right? One formula for F equal to mg. And what is m out here? So it is the mass of a body, whatever body. Like for example, we are talking about an apple. So mass of an apple. Okay. Second thing now, we have also learned second formula. What is F is equal to capital G m1 m2 upon r squared. Now guys, what I'm going to do, I'm going to, instead of m1, I'll write m, because mass of body I've taken is what? M. Then in place of m2, what I'll do, I'm going to write capital M. What is capital M mean here now? Mass of Earth. Anybody remembers what is small r here? What does small r mean?
It's a second.
Distance.
Distance
Distance
of
of separation.
separation between the Earth and the object. Guys, let's say this is the side of the Earth. Okay, and center of the Earth I'm not able to mark over here. And you have another object A here. Now let's say distance from A to this Earth is say 100 meter. Anybody knows what is the radius of the Earth? It's given in your physics textbook. I'll just check. Guys, radius of the Earth is.
Sir, it should be around 15,776 by
Brother. It is 6, 3, 7, and 4 zeros. 1, 2, 3, 4. So that is a value they have given, maybe approximate value, whatever. So these are value they have given. 6 point. Even वापस check कर लेता हूँ. Shyam, you said how much?
So I didn't say Aditya.
Acha. Aditya 6.6370000. Yeah, this is the radius given, but it's given in meter. Yeah, this much is the distance. Guys, so this is the distance, okay, radius of the Earth. So what's the total distance between the A and the center of the Earth? You'll add both the values, right? 6370000 plus what? 100. Look at the answer, guys. There is barely any difference, right? You see, like compare these two values. Does it make any difference in the distance? No. So what we do, for practical purpose now, we take it the whole distance as capital R only, like radius of the Earth. Because you got it now, radius of Earth is so high. Got it now, it is so high that when you add a small value like 50, 100 meter, 1000 meter, 2000 meter, doesn't make any difference. Clear, everyone, guys? I'll give an example. Let's say Vidhi Kalra has a lot of wealth, like say worth rupees some 1,000 crore. Okay. And then her friend, Naisha, she gives her 100 rupees. Okay. Is it going to make any difference to Vidhi's wealth? No. You got to know that because they already shared a very huge amount. That's why it doesn't make any difference. So guys, for the same reason, what are we going to do? Now we are replacing this with R squared, capital R. So what is capital R here once again? Radius of the Earth. Now guys, we have got these two equations for force. So you know what, from both the formulas, what are we calculating? We are calculating the force only on a body. Now, because both of them are for force only, I can compare them, right? I can equate them. So see now what you get on comparing them. So we will get mg is equal to g m upon r squared. Can we cancel anything, Aditya, in this equation? Check. We can cancel the.
Yes, we can cancel the value of m.
M, correct. So what is the equation finally now? G is equal to gm upon r squared. Okay, sorted even now. How to derive this? So guys, they can ask you this derivation. They asked you last year also for 2 marks. Okay, next one, guys. Now, they can also ask you about. Okay, one more thing now. See, this is interesting. You don't need to learn this, but I'm just telling you. So, say for example, if you want to find the value of gravity now on Earth, what will you do? You know the value of G already, right? Here, guys, 6.67 into 10 raised to minus 11. Write down the mass of the Earth, whatever it is. Put the radius of the Earth. And when you do these big calculations now, you'll get an answer, which is approximately how much here? 9.8 meter per second square. So this is the value of gravity. Okay, this value of gravity on what? On Earth. What if you have to find the value of gravity on Moon? Then how will you do it? So you just put the values of mass of Moon, radius of Earth, and then put the value, substitute, you get the answer for gravity on Moon. Okay, for those who do not know, just I'll tell you now that gravity on Moon is 1/6 of the gravity on the Earth, approximately. You know what does it mean? Actually mean, like in practical, in simple terms. Let's say, for example, you give a ball to Devansh Chawla and you ask him throw it up, on a, like, let's say you can throw it up to third floor of a building. If you ask him to throw the same ball, on the Moon, it will go to which floor? It'll go to 18th floor, guys. Okay, not that he's got some superpower. Then it is because there the gravity is only what? 1/6, so that ball can rise up so high. Okay, so now, guys, what is the gravity on the Earth? It is 9.8 around. So on solving, you'll get how much? 1.6 meter per second square. Clear, guys? Everybody? So this is the gravity of the body on the, gravity on the Moon. Now, if they ask you what will be the weight of a body on Moon, how much will it be? 1/6 of the weight of a body on Earth. Why? Why will it be 1/6?
Because gravity
The
is 1.
reason is exactly because the gravity is 1/6, so weight also becomes 1/6. Anybody remembers the formula for weight? The formula for weight is same as the force, gravitational force, mg. Okay. Another thing, guys. Now, if you drop if you drop an object from top to bottom somewhere, say we are dropping an object, what will be the initial velocity when you drop an object? Aditi, what will be the initial velocity when you drop an object?
0.
0. So u is equal to what? 0. Okay. Anika, what was the formula for W?
So W weight was equals to the basically it was equal to force is equals to mg.
M into G. M into G.
I mean,
You can write A also, but here because it is gravity, we are writing G. Okay.
yes.
Yes. Now, when you throw a body upwards out here, what is the final velocity of a body? Sorry, I wrote it down wrong. Okay, what will be the final velocity of a body when it is thrown upwards? At the highest point, what is the final velocity? Highest
So
point.
0.
0, correct. Because if it is not 0, that body will never stop. Na chalte jayega upar. It will keep going up. Okay. Clear, everyone? Then, guys, next thing. Also, what about the gravity? So, acceleration due to gravity is not positive. When you throw it downwards, drop downwards. And when you throw it upwards, acceleration due to gravity is what? Negative. Clear now, everyone? Fine. Now, guys, okay, and one last thing. Who's going to restart the meeting? New meeting? Chawla, you, na? Who's doing it? Sorry, somebody was there, na? Okay, anybody who can do that, restart the meeting.
Yes, sir.
Zia, you're doing right.
Okay.
Okay, let's see now. Let's say, okay, now what is the difference between the mass and the weight of a body? So first thing is, what's the symbol for mass? M. Weight is what? W. Remember, these not a point of difference. So some innocent kids, they write that also, M for mass in the exam and W for weight. So that will not be a point of difference. We can write what is the difference, First point is what you can write the definition of them. What is the definition? Mass is the matter contained in a body. Might have done in 5th, 6th, 7th standard. What is the weight? Gravitational force acting on a body is called as a weight. Then what is the unit to measure mass? Kg. What is the unit to measure weight? Newton. Okay, then guys, which is a scalar quantity out of this two?
Mass.
Correct. Mass is scalar quantity. The vector quantity out of these two, weight is a vector quantity. Then next thing, which instrument is used to measure mass? Anyone knows?
Beam balance.
Balance, yeah. Spring balance also.
Correct. Beam balance. We use... No. Beam balance only for mass. And we are using spring balance for finding the weight of a body. Okay. So guys, these are the enough like this differences you can write. Just one more thing, mass of a body remains constant if you know. So you go to any planet, your mass will remain there. Yeah, Jia.
No, I was asking you for the recording.
Acha, okay. Yeah, Aditya, read na, sum number 2.
Sir, I don't have the book currently. I'll just get it.
Acha.
1 second.
Nishtha, you have?
Yes, sir.
Yes,
I
sir.
have.
Yeah, okay. Jaggi.
What is the force of gravity and weight of a block of mass 10.5 kg?
Hey, Nishtha, you are reading some other sum.
What? You said 8 sum, na?
No.
Oh, second. The value. Oh, write the approximate weight of a body of mass 5 kg. What assumption have you made?
Okay. Guys, underline the word assumption. So what is the assumption? Now we don't know the gravity. So because they have not given us the gravity, we'll have to assume. So let's assume gravity is how much? 9.8. Remember, don't take it as 10. Your school, I don't think gives you correct if you take it as 10. So
In the textbook, it's written 10.
yeah, but your school does not accept. Like last year, few kids lost marks also for that 3 marks. Okay. Yeah. So now you know how to solve it, guys. It's very easy now once you know the gravity. So what is the formula for weight? W equal to mg. Mass is 5 and gravity is 9.8. 49 Newton. Then guys, third term. I'll do one thing. I'll explain you all the problem. Then you can do them all together. I'll keep it here only on the board. Okay. Guys, problem number 3. Yeah, read na, Jaggi.
Calculate the weight of a body of mass 10 kg in kgf and Newton.
So guys, this is the Dhasu problem. You will not feel so when I solve it, but it's actually very, very tough problem. People usually don't get it in exam. So first you want to find in kgf. Now see how to calculate in kgf. W is equal to what? Mg. Mass is 10 kg. So whenever you're not putting the value of gravity, then we write kgf, which means what? Kilogram force. Okay, remember guys, see, it's very simple, but still very confusing, very difficult to remember. When you don't put the value of G, you write kgf. It was kilogram, so it became kilogram force. And what's the second part of this now? So W is equal to what? Again, mg. Mass is 10. What is the gravity? What's the gravity given, Jaggi?
9.8.
Okay. So you multiply them, 98 Newton. Fine. Guys, then problem number 4, underline the word magnitude and direction in that problem. Angel, read the problem.
State the magnitude and direction of the force of gravity acting on a body of mass 5 kg. Take gravity as 9.8 meter per second square.
Okay, what is the formula for W? mg. So mass is 5, gravity is 9.8, 49 Newton. Okay, so this is the magnitude. So you know meaning of magnitude, right, Krisha? It means a value. Aditi, close your mouth. And direction will be what, guys? Here we will like vertically downwards. So it will be vertically downward. Good, na everyone? Then problem number 5. Yeah, Krisha, read.
The weight of a body is 2 Newton. What is the mass of the body? Gravity is equal to 10 ms square.
So I can leave it now. You'll think you can do on your own. Weight is given, gravity is given, find m. Same formula. I'm leaving guys for now. If you don't get, then we'll discuss later on. Sum number 8. Yeah, Krisha.
What is the force of gravity and weight of the block of mass 10.5 kg? Take gravity 10 meter per second square.
So mass is given 10.5 kg. And what else? Gravity is given how much you said?
Yes, sir. 10 meter per second square.
10. Okay. So Anika, tell me which formula will we use here? Anika, your video is also off. You're not responding also. Anika, are you in there?
So I'm lagging a bit. Can you just give me 1 minute?
Yeah, what lagging? I said even if you're lagging, you keep your camera on. I don't mind. It's okay. You'll get logged out. I'll again let you log in. I don't want your cameras to go off, Anika. You can
Yeah,
hear
so
what I'm
just a
saying, but you
minute.
cannot hear my question, which I asked you.
So just a minute.
Ashi, what formula should we use for W?
mg.
mg, yeah. That was also she couldn't answer. What lagging? Mass is 10.5. What is the gravity? 10. So it'll be 105 Newton. Okay. Next one, problem number 10, guys, all will try on your own. Okay, start solving it. So these are the problems I want you to do right now. Start from 2 onwards. I'll check your this work also in the class next time.
Sir, could you explain the first part? How did you get kgf again?
So see, whenever you're not putting the value of gravity, that is G, then your answer will come into kgf, kilogram force. And F just means what, gravity is still acting on it like that.
Okay, sir.
So should we do 2, 3, 4, 5, 6, 7, 8, or should we do 2, 3, 4, 8, and then the other ones?
No, only the one which I've marked actually. 2, 3, 4, 5, 8, 10.
And 8. Okay.
So in the fifth one, should we take gravity as 10 or 9.8?
Yeah, I'll scroll it up. All are done, third one. If you're not getting 5, 10, let me know.
Sir,
Yeah,
in the fifth one, should we take gravity as 9.8 or 10?
they have given gravity, Angel. Then you'll have to take what they
10.
give you.
But okay.
So basically, if they ask to take assumption, then we have to take 9.8 instead of 10, right?
Yeah. ये તમે solve કરો છો ને? Okay. Everyone's done till 10. Guys, we'll do sum number 12 now. Put a tick mark now on the sum which we've done so we know next time what will be finished. Aditi Doshi, read sum number 12.
Sir, did you hear? Like I spoke the question.
I don't know. I did not hear. I don't know if others
Sir,
heard you.
My camera has some glitch.
Everybody heard you?
Sir, pata nahi. Sir, read it again. A body is dropped from the top of a tower. It acquires a velocity of 20 meters per second. On reaching the ground, calculate the height of the tower. Take gravity 10 meters per second. Sir,
So,
my
body
camera
is
has some
falling.
glitch में 2 मिनट में कर.
Is dropped from the top of a tower. So who is the U? 0. It acquires a velocity of 20 meters per second. Calculate the height of the tower. So S is equal to H is equal to question mark. What is the acceleration due to gravity given to us? 10 meters per second squared. Somebody can suggest which formula should we use here? Aditya.
Sir, V is equal to U plus AT.
Anika formula. I've written the hint. Aditya बोलो. यार किसको नहीं आ रहा है formula?
U square plus 2as.
Correct. Use this formula. So who's the V? 20. U is 0. 2. A is 10. And S we don't know. So 400 is equal to 0 plus 20 S. What is 0 plus something? That number only, 20 S. So S is equal to 400 upon 20. 20 meter. Those who are done 12, they will try 15. Anika, read 15 sum.
15th, right? Okay. How long will a stone take to fall to the ground from the top of a building, 80 meter high? And B, what will be,
It
what
is
will be the
U is 0. A is equal to G equal to how much? How much is it given, Anika?
G is 10 meter seconds minus 4. What will be the velocity of the stone on reaching the ground?
Correct. And you have to find out time also, right?
Yes.
And height is given. So S is equal to H is equal to 80 meter. Okay. Guys, try. Or you want me to give out the answer? First one, you can use the formula V equal to U plus AT. Na? Directly you'll get with that. Gajaria, got it or no?
So done.
There are two parts, guys. Hey, nahi aayega. Guys, we can't solve with this formula.
First, we'll use V.
No, I'm-
V square plus 2AS.
S is
V
equal
square
to
equal to
UT.
U square plus 2.
You can do V square equals to U square plus 2AS.
But then we don't know V also, na, Jia.
You have to find V, and then in the end, you find time by using V
Acha, हाँ.
plus 80.
Correct.
We have U by A now.
I mean, तो U कितना है? 0. A is equal to G is equal to 10. S is 80. So it is 1600. So V squared is 1600. So what is V equal to? 40 meter per second. Okay. Then guys, you can find out here also, na, V equal to U plus 80. But V is how much? 40. Let's try sum number 18 after this. Who got 18 one? Vidhi got?
Yes, I got it.
Yeah, sir, even I got it.
Okay. Which formula, Angel? S equal to UT plus half AT square, na?
Yes.
Yeah.
Angel, which one did you use?
No, I did the same way we did the last one. V equals U plus 80 and then V square equals U square.
Acha, okay. But you could have done directly also. Anybody did in one step? Directly?
Yeah, the half 80
Yeah, the
square.
UT plus half 80 square.
Yeah, correct. Yeah, did we do sum number 7 or? No, no.
Yeah,
No.
I mean, I did it. We
Acha.
can do it right now, but
Guys, for homework, we will do exercise 3E. All questions from 1 to 22.
Sir, could you repeat?
It's here on the board. Can somebody post the homework on the group? I'll also send this on the group
Around
later on the
20
PDF.
questions.
Sure.
22 are there.
दूसरे तो
Questions. I'm not saying numerical questions.
अच्छा
Okay. Dia, you send me the recording now, both of them, whenever like you can.
Yes, once they're
And
converted.
okay. And guys, yeah, fine. I'll send you the PDF. Guys, everybody will copy down these notes also. Okay, like those whatever derivation on made. Those who not written, they'll write it in the notebook. Copy it down. Okay. Bye everyone.
Bye, so thank you.
Thank you.